The objective for making this video is to discuss previous year MAKAUT question paper solution on electric machine 1 subject. Today, we come with Group D question answer. So, the first question is, draw and explain the methods of speed control of DC motor by flux control method. Discuss the ranges of speed control by the flux control method. Before answering this question, we have to know what are the key points which we have to mention for answering this question. First of all, you have to mention the speed equation of DC motor. Then you have to define the different parameters through which you can able to change the DC motor speed along with the field flux control method. And then this method should apply to the shunt motor and series motor respectively. After that, you have to give the answer of second question, that is ranges of speed control by the flux control method. So as per the requirement, first of all, I have mentioned the speed equation. From the speed equation, you can see there are three parameters through which we can able to change the speed of the DC motor. These are voltage, armature resistance RA, and field flux phi. But the important thing is that when we are trying to change one parameter, the other parameter should remain constant. Okay, and as field flux phi is directly proportional to field current, thus the speed control by this method, that is the field flux control method, is achieved by control of the field current. Next, we are trying to apply the speed control to DC shunt motor and series motor respectively, along with the respective diagram. So as you can see, this is the circuit representation of speed control of DC shunt motor by field flux control method. So with the help of this rheostat, that is RC, we are trying to change the value of field current so that we can able to change the value of speed. Whenever the value of resistance is 0 and we are giving the applied voltage, at that time rated field current is passing through the field winding and we are getting the rated speed of the motor. But when we are trying to insert this resistance in series with the field, the value of the field current will be decreased, and so that the speed of the DC shunt motor will be increased. In case of DC series motor, we can apply field flux control method by using a diverter or by using tapped field control. The objective for both the method is same. We have to change the field current so that we can able to change the value of speed. But the way is different. As you can see, in case of diverter, we are trying to insert a variable rheostat in parallel with the field, and with the help of this we are trying to control the value of field current so that we can able to control the speed. Again, in tap field control method, we are trying to change the value of field current by tapped field control. Again, here we are trying to change the ampere turns by varying the number of field turns, and so that we can able to control the value of field current. And lastly, we are trying to change the value of speed. In both the cases, we are getting the speed more than that of rated speed. And with this discussion, we can easily find the second answer. That is, this method is applicable for the speed beyond the rated speed. Okay. So this is the answer of the first question. Now coming to the second question. The second question is, what is commutation? Briefly explain the factors that enable sparkless commutation in a DC machine. So again, for answering this question, you have to know what are the key points which you have to mention for answering this question. The first of all, you have to define the process commutation, how it can be achieved, that you have to also explain, and then you have to conclude when the commutation is to be good or poor respectively. And definitely, last but not the least, you have to mention the different methods through which we can able to improve the commutation. Okay, so first of all, what is commutation? Commutation is a process of producing a unidirectional or direct current from the alternating current generated in the armature coils. The current generated in the armature conductors of a DC generator are alternating. These currents flow in one direction when the armature conductors are under north pole, and the opposite direction when they are under south pole. As conductors move out of the influence of the north pole and enter south pole, the current in them are reversed. That is the very important thing which you have to keep in mind. When a brush spans two commutator segments, the winding element connected to those segments is short-circuited. During the period of short circuit of an armature coil by a brush, the current in the coil must be reversed and also brought up to its full value in the reverse direction, and that is the actual mean of commutation. Okay, and the time of short circuit is called the period of commutation. Okay, and commutation is said to be good if there is no sparking between the brushes and commutator when current reversal in the coil section takes place. Similarly, it is said to be poor if there is a sparking at the brushes during current reversal in the coil section. And last, I have mentioned the different process associated with improvement of commutation. That is, by reduction of inductance and increase of resistance of the commutating coil, we can improve the commutation. Shifting brushed from GNA, if we are trying to shift the brushes from the geometric neutral axis, then also commutation will be improved. And the most important thing is that by using compoles or interpoles, okay, we can able to improve the commutation. And last but not the least, we can also use compensating winding. Okay, last but not the least, we can use compensating winding, and through which we can also improve the value of commutation. So this is the answer of this particular question. Now coming to the next question. Explain 3-point starter with net diagram. For answering this question, first of all, you have to mention the constructional features of 3-point starter very briefly. Then you have to draw the schematic representation of 3-point starter. And then you have to discuss the working principle of 3-point starter followed by drawback of this starter. So these are the things which you have to mention for answering this particular question. So as its name implies, 3-point starter, it should have 3 terminals actually. And these terminals may be designated as L, A and F. L stands for line terminal, A stands for armature terminal, and A for Z stands for field terminal. Okay, and line terminal is connected to the positive supply. A terminal is connected to the armature winding, and A for Z terminal is connected to the field terminal winding respectively. And this starter is mainly used for DC shunt motor. Okay, and the most important thing is that actually 3-point starter is nothing but the variable resistance connected in series with the armature along with 2 protection. One is called NCV, another one is called overload protection. One is called no voltage protection and another one is called over voltage protection. So these are the basic structure of 3-point starter. Now I am trying to discuss the working principle of 3-point starter with the help of this diagram. So mind it, the schematic representation of 3-point starter is very much important. Okay, so that you can easily explain the total phenomenon related to 3-point starter. As you can see, we are giving the supply voltage V. Okay, and as I have already mentioned, positive terminal is connected to the line terminal. So when the switch is closed, the current is passing through the L terminal and that goes to the handle, this arm, through overload coil. Through the overload coil. And when this arm is coming to the position number 1, then the total current is divided into 2. One current goes to field through no voltage coil and another one is coming to the rheostat that is connected over here. That is R1, R2, R3, R4, R5 respectively. And at the time of starting, the arm position should be in one position, and then after the starting, we are trying to gradually decrease the value of resistance, and at the run position, the value of the rheostat or the value of the resistance becomes 0. So the thing is that whenever the current is passing through the overload coil, it will not energize this coil. The designing feature is like that. Whenever the current carrying capacity is more than the rated current, at that time this coil will be energized. Okay, that is the one thing which you have to keep in mind. And whenever the field current is coming to the no load voltage coil, at that time this coil will be energized. And as you can see, a soft iron portion is connected to the arm. And as this no volt coil is already energized, so whenever this arm is reaches to position run, then it will be attracted. This soft iron portion will be attracted by the no volt voltage coil, no volt voltage coil, no voltage coil. And the arm will be at position run. So automatically it remain in run position. Suppose there is a loss of voltage or by chance the supply voltage will be disconnected. At that time, the no voltage coil will be de-energized and that will automatically push this handle to off position. That is the thing which you have to keep in mind. Again, as I have already mentioned, during the normal current passing through this overload coil, the overload coil will not be energized. But whenever the current carrying capacity is more than the rated current, the coil will be energized. And as you can see, below this coil, there is a lever. So whenever this coil will be energized, it will push the lever into the upper direction. And at that time, the no voltage coil will be shorted. And the no voltage coil will be shorted means it will be de-energized through this path and then automatically push back to the arm into off position. So that motor will be off. So motor will not be damaged. So these are the things which you have to mention in the working principle of 3-point starter. But the important thing is that is the drawback of 3-point starter is what? Whenever the current reaches to field winding through no voltage coil, and if we are trying to apply the field flux control method, so the value of decreasing field current will be affected to the no voltage coil. And at that time, it will be de-energized and the handle or the arm is automatically pushed back to its off position. So this 3-point starter cannot be applied for field flux control method. And this drawback is overcome by 4-point starter. So these are the things which you have to keep in mind regarding this question. Okay. So all those things are there. No volt trip coil, as I have mentioned, as no voltage coil, overload coil, like that. And also drawback is mentioned. Now coming to the next question. For any DC machine, prove that E is equals to P5 Zn by 60A. Okay, P5 Zn by 60A. Just a minute. P5 Zn by 60. So these are the question. This is the question. That means you have to establish the EMF equation of a DC machine. For answering this question, first of all, you have to designate all the parameters associated with the DC machine. And then you have to apply the mathematical representation so that you can easily develop the EMF equation. So first of all, phi, that is the flux per pole in Weber, Z, total number of conductor of the armature, P is the number of poles of the machine, A is the number of parallel paths, and N is the armature speed in RPM, and EG is the generated EMF in any one of the parallel paths. As I have, all of you know, the voltage across each and every parallel path is same. So if we can able to find out the voltage across any one of the parallel path, then we can easily determine the EMF induced by the DC machine. Okay, so EG is generated EMF in any one of the parallel path. Now, flux cut by one conductor in one revolution is what? As the machine have p number of poles and flux per pole is 5. So flux cut by one conductor in one revolution is equals to P5. Now flux cut by one conductor in 60 seconds is what? P5 n by 60, as n is in RPM. So what will be the value of average EMF generated in one conductor? That is P5 n by 60. Now, as total number of conductors becomes Z and number of parallel paths become A, so how many conductors are connected in series with per parallel path? How can you find out? Just you have to divide Z by A, and that you can easily calculate the value of conductor connected in series per parallel path. So Z by A is the number of conductor connected in per parallel path. So average EMF generated in one conductor is P5 n by 60, and total number of conductors in each parallel path is Z by A. So what will be the value of EG? That is P5 nz by 60. So finally we are developing, or we have developed, the EMF equation of DC machine. The next question is, there is a numerical which you have to solve. As you can see, a 50 kVA 1000 by 100 volt single phase 2-winding transformer is to be connected as an auto transformer as shown in figure. Find kVA rating of the auto transformer. One thing which you have to mention for this question is, no figure is mentioned in the question. As per the given data, I have tried to make the circuit. Okay, so this is the circuit representation of the numerical given. So how can you calculate I1? I1 can be calculated as total kVA is 50. So first of all, you have to convert into the VA. So 50 by 1000 divided by 1000. So we are getting I1 as 50 amps. Next, you have to calculate the I2, that becomes 500 amps. So what will be the total current into the primary side? That is 550 ampere. Okay, and what will be the current associated with, I2 is 500 amps. So what will be the value of IA1? That I have already mentioned in this picture. IA1 is equal to 550 ampere. Okay, so kVA rating, how can you calculate the kVA rating? Corresponding to primary side as well as corresponding to secondary side, you can calculate. So 550 into 1000 or 500 into 1100, that gives the 550 kV. So the kV rating of the auto transformer becomes 550 kV. Okay, so with this I would like to end my today's video, and I will definitely come with group C question answer very shortly. Thank you very much.